Okay, this separation method that we are going to look at is your chromatography. So the logic to use chromatography, this one is used to identify small amounts of substance that are dissolved in solvents. Okay, the principle behind it is that different solute have different solubility in a particular solvent. Okay, the more soluble the solute, the further and the faster it will travel. Okay, so your chromatography will look something like this, like a piece of filter paper. Okay, and then in this filter paper you will have to draw your starting line, and then you put a sample of mixtures of solute with different solubility. So for example, the pen ink that you have, okay, even though it is red, it can be made out of multiple different color mixed together. Okay, so what can we do when we put the sample ink over here and then we put it inside a beaker of some solvent? Okay, most common solvent will be water, right? What happens is this water, when I soak it inside your chromatography paper, your water gets absorbed and then it will reach the sample ink that you put. When it reach the sample ink that you put, because the sample ink is a mixture, right? The water will dissolve the mixture and then it will continue to get absorbed up the chromatography paper. Okay, so when it gets absorbed up the chromatography paper, it will form some dots along the way, right? So it forms, actually in this case, maybe 4 dots, for example. So when they form these 4 dots, when the dots are formed, these 4 dots are formed represent that there's actually 4 components inside the sample ink originally. Okay, and then each component maybe will show a different color. Okay, and in this case, your red dye, right, which makes from this original ink, right, it is the most soluble because it travels the furthest. Your yellow dye, which is also made up from this ink, this original dot that we add in, right, the sample that we add in, this is the least soluble. Okay, so what we are going to do in chromatography will be something like this, right? So we add and sample ink, okay, and then you know that your sample ink actually separates out into this same thing. This is 4 dots, so it separates out into 4 components. Okay, then we know that there is like a pure P, pure Q, pure R, and pure S. Same thing, when we put this pure substance on the starting line, right, it will only separate into 1 dot, okay, if they are pure. For example, your R and S. Okay, your R and S are pure because it only separates into 1 dot, right? Okay, and then after that, what do? We can actually draw a line across. If they lie on the same line, okay, it means that this first dot in your sample ink is made from component S. Okay, same thing if we continue to draw a line over here and here. The second dot and the 4th dot is made from component P. Okay, and then this one over here, this dot over here is made from component R. So this sample ink, right, is made from P, R, and S. Q is absent because they don't lie on the same line. Okay, so results of your chromatography, right? Sometimes when you do your chromatography, you will have 1 dot. Okay, when you have 1 dot, this one shows that it is a pure substance. Okay, 1 dot and then nothing left here, right? Nothing left at your starting line. It is a pure substance made out of only 1 thing. Okay, chromatography B is a mixture of 1, 2, 3 substance. Okay, same thing, there is no dot here anymore. Okay, it separates into 3 dots, so it's made out of 3 substance. Okay, and then your C, your sample will remain here. There is no dots along here that you see. Okay, there is no dots over here. So if there is no dots, it means that there is no soluble substance. No soluble substance because your sample ink remains here. Okay, let's look at the next part where we look at some of the precautions that we have to take when we do chromatography. Okay, the starting line must be drawn with a pencil. Okay, it cannot be drawn with a pen ink. Why? Because the ink will dissolve. Ink is made out of mixtures of solute, so it dissolves. Pencil, it is made from carbon and it is insoluble in most solvent. Okay, most common solvent we use is water. Sometimes we can use alcohol, we can use sugar syrup, etc. Okay, spots of the solution and dyes on the starting line should be small and concentrated, meaning to say the original dot that you put it as small and as concentrated as possible so that they will separate into distinct line. There will not be smudging. Okay, and then small and concentrated, this one you also minimize wastage. Okay, the solvent line must go as near the top as possible, right? So when you start your chromatography, your water, the solvent will start to move up. Okay, make sure your solvent will move up to the top of the chromatography paper as close as possible. This will allow that all dyes are separated. Okay, so for example over here, this picture, my solvent line runs up till here. Okay, what happens if, for example, I stop all the way here and then there is a dot here? Then if I stop here immediately, I cannot see this separation, right? So I must let it run all the way close to the top so that you know this last dot, which is very soluble because it's the furthest away, can be seen. So this allows for effective and maximum separation. Okay.